I'm honoured to be on the ancestral lands of the Gadigal people. I acknowledge the first Australians as the traditional custodians of the continent, whose cultures are among the oldest living cultures in human history, and I pay respect to the elders of their communities. Thank you very much for having me here this morning. I'm really honoured to be participating in concrete. My engineering career started with concrete. I was doing capping beams at number 3 Berthdale Harbour. It's now fascinating for me to see that it's now parkland, back to the original profile of the land that was there before we put the capping beams and turned it into a wharf. So in terms of how history can change things enormously in one lifetime, I think my engineering career rather shows that. I never expected to be walking around a park after spending those years there. I would like to endorse everything that David has just said. I think many of the stories that he was just saying, I'm thinking, yes, I remember when that happened, and yes, all of that is very relevant to the way I have experienced engineering, and I still experience engineering because I am now doing independent assurance for defence. So I'm seeing engineers now working together across complex systems where communications and the requirement for infrastructure to be interoperable really does change the dynamics of how we have to think about anything. So seeing all of those very complex diagrams is my lived experience in my working life today as well. But what I'm here to talk about is how we are, and I might just move this so I can, are both working? Yes. So I can also see my slide and the next slide and keep a sense of where I'm up to. The future of engineering education, I'd first like to situate that in terms of the challenging present and future that we are now having to live with, and why that is important in thinking about the changing mindset that we will have to bring, and to how we think, the cultural norms that we will have to embrace and rapidly are already trying to embrace as we move forward in engineering. And the response that engineering education, I'd have to say in a very haphazard way to date, is trying to undertake to respond to what is going on. I'd like to start within a definition of engineering, and I like this definition because it actually doesn't mention science. One of the things that we often are considered to be is applied scientists, and for me nothing could be further from the truth. Our objectives, our focus, the way that we operate is certainly fundamentally informed by, and it is a very invaluable tool that we use. But if we continue with the mindset that we are just following scientific innovation, or the community believes that that's what we are doing, then there are a number of dimensions of engineering as a profession that get lost with that, and that drips itself into the way we structure our curriculum, and it drips its way into why we don't think about communications as important, why we don't understand the need for teamwork in the way that we have just been presented with in the last presentation. Engineering is never static, of course, because of science, naturally, but because also of a number of other elements that I will probably concentrate on more fully through the rest of the presentation. We are now in a situation where the physical, digital and biological are blurring, and I see that every day in the work that I do in defence. We are a melting pot of technologies and cyber-physical systems that really do increase the complexity of what we are required to do. We are, in that sense, almost anticipating that we are at the start of another golden age of engineering. And as with each other industrial revolution, most of our rhetoric tends to be around extolling and putting to the side those uncomfortable voices that may ask questions about the validity of much of what we are doing. So we do have a lot of discussion. We do believe that we are being very open-minded about how we engage with the technologies that we are bringing. We make assumptions about how those are going to improve life. But there are other voices out there that we do tend to not listen to at times. And probably the story of plastic. And this is not about bad people, good people, all of that sort of thing. It's about we all made decisions, me included, at a time and a place where there was a particular way that we were situated in the community with a certain level of expectation about the constant giving that the community, that the environment would give us in terms of resources. That was okay for the 60s, 70s, 80s when we didn't know as much as we know now. What I am suggesting is that to take that mindset into the future will be inappropriate and will be seen to be inappropriate for us as professionals. And the story of plastic is that when I was growing up, it became the most wonderful thing that any of us ever had seen. We had toys that we had never seen before. We had capacity to look after food in ways that we had not seen before. But there has been a cost. And we are now very conscious of that cost. That at the time we were extolling it, we didn't anticipate. We are now even more conscious of that cost because the rest of the world has decided it doesn't like our rubbish. And so we are now actually going to have to deal with our rubbish rather than ship it off where we couldn't see it. That has led, as we have seen over the last little while, and is increasingly becoming the centre of the discussion, that the idea of a circular economy as a strategy to deal with a different way of understanding the finiteness of the resources that we use as engineers will mean that we have to work on a different model of how things are done. And a lot of this is already being actioned, and in looking at a number of the papers that are here today, it is certainly something that everyone here is very conscious about. Taking that then into the concrete arena, concrete has transformed our lives. I now go swimming up in Yeppoon with my grandchildren. On one of those slides, I know that in one of those photos that the winner last night is one of the other slides. They are beautiful. Concrete has made our lives stunning in the same way that plastic made our lives stunning. But we also need to recognise that there is another rhetoric, another story that is going in parallel with our own joy and pleasure in concrete, and we will need to deal with this in the future. We will need to understand the concerns that the communities and others have about the work we do. So while we are doing an enormous amount, while there are many things that are to be celebrated in how we are taking responsibility for the changes in the way that we need to relate to finite resources, we've only just started on that journey, and it is likely to take an even greater shift in mindset quickly over the next little while. Because there has been a shift in our relationship with the community that will impact on how we are expected to operate, in terms of how we are expected to have a greater level of responsibility to anticipate issues that will arise in the future rather than just respond to those, to embed in an anticipatory way a number of emerging themes in the community rather than waiting until they have become so in the public media that we then are perceived only to respond to them. There has been an erosion of our social licence to operate. The legitimacy, the credibility and the trust that we have always had as engineers has been eroded by a number of stories around the way many of the technologies and the negatives of some of those technologies are playing out in the public space at the moment. We need to address this, and we can only do so with a fundamental shift in our thinking and in our education. And this was really brought home to me because somebody said to me, well, you engineers, the more you create, the more problems you create, you then just create the solution. So you don't have any invested sense of responsibility for what you're doing because you'll make money whichever way it goes. And to hear that about a profession that I'm very proud of and that I think does an enormous amount of good just made me reflect on sometimes it's very important to hear those other voices because actually that's quite right. That is exactly what we are doing over the plastics. And we are going to be expected to do a lot more. This is also occurring because for the first time, the UN is now trying to build a blueprint for the future that will address a lot of the global challenges that we face. Some of them already there, some of them a result of historical, geopolitical manoeuvrings by various cultures over time, but a lot of it also because of the lack of distribution of wealth that has been caused by our capacity to do so much in our communities at the expense of other communities in terms of our technological progress. And moving that to some more equitable distribution of wealth is already occurring. So we are engineers who now face a very different context to the one in which I was educated. We now have a fragile planet rather than a planet where we thought it was always going to be there and providing us with what we wanted. We are an interdependent world. We now understand that doing something in one part of the world will have significant consequences for other parts of the world. And there is now an aspiration to leave no one behind. We have moved to a way of thinking that isn't about that there's the developed world that we can just use and the developed world can almost have a slavery mentality towards the rest of the world. That is a significant shift. The capacity of engineers to deal with this complexity, environmental fragility and global interdependence, I believe personally, because I'm very proud to be an engineer, will be crucial in determining what future we have. We are a very important player in this terrain. So our engineering education and how we structure the capacity of the next generation of engineers in alliance with industry people who have the foresight to understand that they will also be part of that education of those young people in how they work with them, in how they socialise them into expectations in industry will be important. I, as a young academic, saw this in play. I worked at UTS for 10 years and we would send students out into industry. The ones that went to industries that were forward-thinking were fantastic, but there is nothing worse than trying to deal with an engineering student who comes back and says, as one of mine did, well, all that rubbish you were talking about the environment's ridiculous because I was working next to Lane Cove National Park and we used to just pour the paint down the drain. And, you know, as my boss told me, all of that other stuff's rubbish. Now, that was in a time and a place. He came back 2 years later and told me about the fine they got, and perhaps there was other issues that perhaps could be considered. But the engagement between academe and industry is an important one. The values that industry provides as a learning outcome for the students is important, and more important than ever moving forward. The difficulty is, as someone who's been involved in trying to be an agent for change in engineering education, is again, and I will put it out there particularly to the industry people, that engineering educators are struggling with how to design engineering for futures, a different sort of engineering. And there is nothing harder than then when senior engineering people from industry come in and say, assume that, well, I knew my professor, and my professor when I was there 30 years ago was, and their whole mental image of education still revolves around a model that was appropriate 20, 100 years ago maybe, but is not appropriate now. So there is a tension in an expectation that industry have of what they would like to see in engineering education, but the reality is that often they come at it with a mindset that still assumes that all the students, to some extent, should be sitting in those lecture rooms like they were 40 years ago, and getting to know lecturers in ways they knew their lecturer when there was only 20 people in the room or 30 people in the room. It's not going to work for the future. So industry people who come into universities need to be as open-minded and not assume lectures are the way to go. In a world where everything can be picked up on the internet, why would you have lectures? Why do we have assumptions about that when there are very different models? The problem then is, without denying at all the need to ensure that our graduates have deep technical understanding, either of specific bits of knowledge or how to access those and manipulate those in constantly shifting scenarios, is never questioned. But there are other ways that a curriculum can be designed to marry that with team building, marry that with cultural understanding. At the moment, I don't think we do it very well. We just assume we throw them into teams. We do none of the nurturing that David was talking about. We do none of the analysis in the engineering classroom that is required to make that a significant rather than a trivialising experience for the students. And the problem with that is then the students will trivialise teamwork because it was done really badly in the university. So understanding that, there is a long way to go. In Australia, we are very privileged to have 3 groups that are working together to manage innovation in engineering education. That's Engineers Australia with their accreditation system, the Australian Council of Engineering Deans, which is an extremely active group of deans who meet together regularly. And one thing that we have that most other parts of the world don't have is a group of academics that about 30 years ago, and I was privileged to be part of the tiny group that set up the Australasian Association for Engineering Education. Now, the reality in universities is the only thing that's privileged is research. And so anybody who was interested in teaching about 30 years ago, you used to go once a year to meet and say you're still sane, because you're interested in something that nobody else in the cultural norm is interested in. But that has now built into a very positive collaboration and site of analysis and moving forward with possibilities for how engineering education might look. There has been enormous shifts over the time that I have, when I was a student myself, then as an academic. And I only became an academic because when I had my first child, you couldn't stay out on site. Otherwise, I'd probably still be out there. So I did come at academia from a very different perspective to most academics, which is probably why I asked different questions. But we have a number of tools, and there is totally different discourse that is going on in engineering education at the moment. But it is a learning activity, and the levers, the KPIs for universities are still weighted to research, which makes learning and teaching still the problematic area when we are trying to shift the culture of universities. I think one of the things that David said earlier is we're all part of whatever system we're in. If you're part of the concrete system, the whole system has to be moving forward together, because if there are parts of it, if the legislation is not assisting, whatever those levers are can either support and facilitate or make life very difficult for the cultural shifts that you would like to make. And the same is happening in engineering education. We have a lot of macro learning and teaching strategies, so there is a lot of complex work going on in universities, and having to rethink. It's not about you just do your slides, you have the same slides for the next 20 years, you rush off and do your research, and hopefully the students will learn something after the number of hours they've sat in a classroom probably learning nothing, or if they're anything like the students I went to uni with, they were all up playing pool, because that was actually where they were learning how to network, which was another important part of doing it. And the only reason I couldn't do it as the only girl in the room, they did notice when I wasn't there. So I sat through a lot of lectures that most of my peers didn't. But for academics today who are genuinely interested in engineering education, there is a rich intellectual work that they need to be doing. And the complexity of pulling together all the different strategies that might be used to give students a range of experiences is very important. The big thing that has really been set up is outcomes-based education. That's a buzzword that everybody looks at, and the parallels are definitely there in the way we move engineering projects forward. Not looking at the inputs, not looking... I, at one stage, used to look after nursing as a PVC, and the way they do accreditation is they count how many beds there are in the labs in the classroom and how many sheets they have next to them, etc., which you would call input-based accreditation, hoping that having those there would somehow translate into learning. Engineering particularly has moved to outcomes-based. What are we looking for? What are the graduate attributes? What's the specification that we are looking for in terms of the expectations of what our graduates will have? And then how are we going to design the system to achieve that? So we now talk in terms of the function model of education, the understanding that we have students, we will move them through a number of activities, the pedagogy, and that will transform them into graduates, and we have to have a process by which we determine whether that has been achieved by that organisation or not. And as chair of the accreditation board, that was one of my roles in the more recent past, was to work on that system. Accreditation visits in terms of external, they're the tests, the external tests that occur on that education system are an important part of the quality assurance process. And it's taking some time to work together collaboratively with universities to get that message through to universities. They actually have to give us their design. It seems quite simple, but it can't be a case of as it was many, many years ago, that we had 6 professors. One knew a bit about concrete, one knew about water, one we sort of threw it all together, and somehow or other we ended up with a civil engineer. There is now an expectation under accreditation that it was be far more sophisticated. I'd call it we're doing the preliminary steps towards that. There is a long way to go, but we are doing now mapping of graduate attributes against activities in curriculum. but the level of sophistication is still very immature at this point. It's a journey that we are all on. It's going to be important for us, whether that is successful or not, how much industry is prepared to be engaged with that journey. At the moment, the Australian Council of Engineering Deans is doing an idea of the Engineer 2035. What will the Engineer 2035 look like? They've done a scoping study, which has just been released. And the reason 2035 was chosen is because the children just starting kindergarten will be graduating in 2035. So what will their lives be like? It's probably too far. Well, we all decided in conversations it might be too far away, but it's the start of really now what are the graduate attributes, what are the expectations that industry will have in 2035. And my first question was, you've forgotten the community. If we go back to that, it's about the community as well. If you're only asking industry, you've forgotten one of your really important stakeholders. Where are the uncomfortable voices? The ones that are just saying, you engineers just do it for the next lot of things you're going to create. Because they will need to inform what it looks like as well. The other area that I am involved with then is the mobility. Oops, I'll go back one. Okay, the back doesn't work. Thank you. The mobility of engineers, there is a thing called an International Engineering Accord. The Washington Accord is one that some people are familiar with. Every international student in Australia is aware of these accords because they're the countries where your degree is recognised. So you can just go over there and your degree will be recognised. This is, and I'm chair of that accord. We all meet and we exchange information on our education systems, and then we give agreement they are comparable, and therefore the graduate from that system can be accepted in another country. And this is a really interesting place to stay because it's not done on a quality like an ISO type of system. Understanding that we all have different needs, we all have different cultures, it needs to be done in a manner that respects and recognises those different imperatives and how we all work them together to end up being comfortable that there is comparison. And some of the language around that is very much about how we need to understand, perhaps in the future, that we talk to stakeholders, that we live together in this very interdependent world, that we do need to learn how to gain insights from our different cultural, socio-political and legal environments, rather than assume that ours will be better, that we can find common ground and that we can negotiate and learn and transform in good faith. And we are having to do that every day in this accord process. I had to work with changes that were happening in Russia, changes that are happening in the UK, sort of the way Mexico is, or Peru is looking at engineering education. We are also just about to start moving to an analysis of the graduate attributes we have at that level against the UN Sustainable Development Goals. Because for all of those stakeholders, as you can see, it's a diversity of jurisdictions around the world with different understandings and different expectations of those goals. So what they mean for all of us collectively is the journey we are just about to undertake now. So I'll leave, I'm moving towards the end, I'll leave with a thought. So I've just done plastic, I've done concrete and how outsiders might view us, and now I listen to all the rhetoric around quantum computing, but I don't hear very much about how we're putting that into a circular economy. I don't hear very much about how we in engineering are dealing with all the learnings that we have learnt, say, from plastics. We're very good at extolling how the extra data will enable us to do all sorts of things, and believe me, in defence, that's a really important thing when you're managing complex systems. But I would hark back to more tests don't necessarily mean a better outcome. So what as engineers is the sophisticated thinking that we are going to do to make sure it isn't the plastics of the next 50 years? Not just even in the physical sense, but also the mining, you could see, perhaps might be, do we have slavery in the mining? What questions are we not asking about how that system is being set up that we are perceived to be oblivious about and therefore less relevant to community in the way that those decisions are being made? So, how will we, as a profession, how will our engineering education be structured to ensure that we maintain the technical competence that we require, otherwise why would we be at the table, but also an understanding of these much more complex questions that we also need to be asking right back at the design phase of how we are engaging as an industry, as a profession, in the technologies that we are using. For all of us, the future will require very different skills, knowledge and attitudes to those that have underpinned the path. And I can see from this conference, I can see from my journey through engineering education, we are all trying to grapple with us, and we will need to work together if we're going to be successful. Thank you.
Thank you very much, Elizabeth. A really thought-provoking presentation there. We do have time for some questions, so if you have any questions, could you please, do we have somebody for the microphone? Yep. Okay, thanks, David. Can you be sure to get speak into the microphone? That's a question up the back there.
Elizabeth, thank you for that inspirational presentation. My name is Michael Van Koeverden, past President and Consulting Engineer, CQT Services. My question really is talking about the future of learning and the future of the engineering workforce and the flexibility in those young, brilliant minds. And we all understand the pressures that these students will be onto when they come into the workforce, because it's quite a different workforce as you've articulated. One of the challenges, of course, is still to keep the fundamentals, so that we're not getting to a point where the students are coming to a flexible workforce, but they're missing those key links that help us to make educated decisions moving forward. And so I see that in the practice and the graduates who go through my business, very smart minds, but there's still some gaps there that need to be fulfilled. The point of the question, I guess, is the 3+2 that's happening now within some education providers, where they're providing the core 3 years with a beneficial additional 2 years. The concern with that type of position, it still gives flexible learners, but we must cover that content. I'll be interested in your comments, please, on that one.
Yes, and I think that goes back to my slide of let's visualise what we are, well, let's think about what we are visualising when we say 3+2, or we say anything about how engineering education is structured in the first place. So that assumes that everybody is going and doing lectures like we did for 3 years, and we can assume that they're getting through a certain content, because as long as we know they were in the classroom and they had a certain amount of time with professors, that they will end up covering whatever content we are comfortable with. The reality is that we now live in a world where the access to the internet means that probably those students can be far more self-learning around the technical content rather than listening to the outdated slides that have been around with a professor. So if you released all the time that students would have having to go to lectures and go through the slides of a professor, and you translate that into an online learning platform, and this has been done at Charles Sturt University because I was part of the development of a course there. Small numbers, and the big universities keep telling me it can't be replicated, but if they haven't done the cost-benefit analysis of releasing all of their academics out of having to do 20 hours of lectures a week, and their students the same, then what time are we released for another model of how we might get through that content? So that's not to deny at all the purpose of that. And Delft University, there's a number of universities in the States that are going along the same line. Students like learning, for example, learning how to do games. So if you set up the curriculum that you can only become a knight if you've learned how to use a sword, and you make that you can only design a filtration plant until you've learned a bit about water, you embed that into a piece of learning software, and there are software companies around the world that are doing that embed tests, that embed opportunities for lecturers to then analyse how the students are going through those tests, and then perhaps have a tutorial on where a lot of the students are having difficulties, or one student is having difficulties. You can actually reallocate your resources in ways that give more effective learning outcomes, in the assumption that if they sit in a classroom for an hour, they've learned something. So it's about turning it on its head. The number of years or the quantum of learning is a really difficult thing, and that actually becomes part of a geopolitical debate about what duration of learning people need. Engineering has come up with 4 years. There is one signatory that would like to make that 3 years. That would put enormous economic pressure on other signatories, because education is a $3 billion industry in Australia, for example. So we start getting into a whole lot of. I just say that only because whenever you delve into anything, it's always far more complex than you believe. I remember one of the most complex reviews I did in defence was of clothing. I never thought clothing could be so complex, and the same with quantum of learning in engineering education. So my answer has waffled a bit, but hopefully what you took from that is you need to go with a clean slate and think about what resources do you need and how are you going to know how the students learn. And it isn't necessarily because they spend 3 years in a classroom in a very, very outdated transmission model of information flow. And if you get away from that, you can really change the dynamics of learning, and you can really change the cost-benefit analysis of the learning outcomes you will achieve. But I go back to that point of, as long as industry goes in and has conversations with the dean, with that old model still in their head, and with the levers around research as a constraint on the deans, then we won't achieve getting them to be good at teamwork as well as having the technical content we require. Did that answer your question?
Yes, thank you. The only comment, if I could allow to respond to that, we still want graduates with some depth of knowledge.
Oh, absolutely.
And
absolutely.
So I take on board what you're saying, and I acknowledge that learning needs to change, but as employers of graduates, we want some depth. We want them to be able to dig deep if they need to, because surface level learning is great and it looks good on the surface, but when you get to the critical time in a business decision, you want quantity and value there. So thank you.
And I would agree with you. I don't think we've done that very well. Going back to that point of it is possible to design a curriculum where you do require them to do in-depth technical analysis, say in a group environment, but we have not as academics yet, designed that to rigorously analyse the learning outcome for each individual in that situation. So that is almost putting people off the idea of things like project-based learning, because the assessment part of it. And I'd have to say it's because some academics, because of their own career process and their investment in research, don't understand that just throwing people in a team, for example, means you learn about teamwork.